Lesson 10.3 is talking about mean absolute deviation, and we've talked about our measures of center. Measures of center, remember, are mean, median, mode. And we've talked about our measures of variability. Remember, that's our range and our interquartile range. And measures of variability talk about how spread out things are, or if they're very close together, the consistency of them. And our measures of center told us about where the middle would be, okay? So mean absolute deviation today, it says you have found measures of center to describe the middle of a set of data, and you have used the interquartile range to describe the spread of the data. The mean absolute deviation is the average distance between each value and the mean. So it's how far apart or how spread out are the points compared to the mean. So it's basically all of it today is the distance from the mean. How far is it from the mean? Okay, so here's the first example. And in mean absolute deviation, the very first thing you do is you find your mean. So you take all of your values, you add them up, divide by how many numbers there are, and that gives you your mean. Then, once you have your mean, you do your absolute value in order to find the distance. So what's that saying? And here it's kind of hard. There's a lot of different, in the notes online, it's actually color-coded to kind of help you follow this. But what it's saying is you are taking your number from the points here. You are taking your mean, and you are subtracting them. Now, when we're talking about the distance between numbers, distances are always positive, so that's why we're taking the absolute value. Because if we want to know how far away something is from 18, well, if we're thinking about 17, that's 1 away. If we talk about 19, that's also 1 away. They're just different directions. So the direction's not going to make it a positive or a negative. It just makes it 1 away, so we're taking the absolute value, so we're always talking about positive values. So you keep doing that. You take your next value and subtract it by the mean, and you get your distance. You take your next value, subtract it by the mean, and you get your distance. You take your next value, subtract it by the mean, and get your distance. Now, that is one way to show the work, and that has a lot of writing involved for something that's pretty simple, just thinking how far away is this number. So I'm okay if in this section you just go through and say, okay, how far is 17 from 18? That's 1. How far is 22 from 18? Well, that's 4. How far is 17 from 18? That's 1. How far is 30 from 18? Well, that's 12. How far is 15 from 18? 3. 17 from 18 is 1, and 8 from 18 is 10. Okay? So that second step is finding the absolute value, which is the distance from the mean. How far away is each point from the mean? The last step is to do the mean of those distances. So we're taking these numbers, we're adding them all up, dividing by how many there are, and then this gives me my mean absolute deviation. If you see it abbreviated like that, that's what it's standing for, mean absolute deviation. Okay? And I want to remind you here of what that's talking about. It says this means that the average distance between the mean points per game and the actual points per game is 4.57 points. Okay? Might make a little bit more sense when we go to try it for the first time on our own. So the first part is, here is our list of numbers. We need to find the mean of those numbers. So I'm going to take those numbers and add them up. and divide by how many there are. And then divide once I have my total. And I get that my mean is 18.8. Okay? There, it's focused in a little bit better for you. So my mean is 18.8. The second thing that I need to do is to find my absolute value, which again, remember, that's my distance from the mean. So I take each one of these and I say, okay, how far away is my mean with this point? How far is this from my mean? Well, the first one, it's really easy. 18 and 18.8, that means there's 8/10 in between, or 0.8. For the next one, let's see if that helps. Alright, for the next one, it's 21. Some of these are more difficult to do in your head, so remember what you would do to find the distance between 2 points is you would subtract them. So if I take my number minus my mean, I get 2.2. And you can continue doing that. Now, the key is, remember, if I would do like this one, 16 minus 18.8, I have to think of it as that's a distance, so that's not really a negative, it's a positive. Okay? So that is taking my absolute value, finding my distance of each one. The last step, I'm sorry that it keeps going in and out so bad today. It's just really, really bad. The last one is going to be we take the mean one more time. So this time around, I'm going to take 0.8 plus 2.2 plus 2.8 plus 0.2 plus 1.2, add them all up and divide by 5. So when I add those up, and divide by 5, I get 1.44 is my mean absolute deviation. Okay? And if it's asking you to describe that, to describe what the mean absolute deviation represents, you're going to think through it as that the average distance between each value and the mean number of tomatoes is 1.44. So let's write that in. The average distance between each data value or data point and the mean, and in this case the mean's talking about the mean number of tomatoes, is 1.44. So it's saying the average distance between these numbers and this is 1.44. Okay? Now, one thing you need to make sure you understand with this is that having a smaller mean absolute deviation means that the numbers are actually closer to the mean, where having a larger mean absolute deviation means that the numbers are more spread out or varied compared to the mean. Okay, so that's what it's explaining here. A data set with a greater absolute value, greater mean absolute deviation has data values that are more spread out from the mean than a data set with smaller mean absolute deviation. So we can kind of compare more than one set. It says the data sets with greater range may not have the greater mean absolute deviation. So that's just a watch out. Sometimes people think that range tells us which one will have a greater MAD or mean absolute deviation, and it doesn't always guarantee that, okay? So example 2 goes through 2 sets of data finding the mean absolute deviation. They started by finding their mean. So on a dot plot, make sure you're going through and reading it. This list would be 59, 61, 62, 63, 64, 64, 64, 67. And for the boys' heights, it would be 60, 61, 62, 62, 64, 65, 72, 74. Okay? So they're adding all of them up, dividing by how many girls there were, and the mean here is 63. So then they took each number and said how far away 63 was with that number. So the first one, 59, that's 4 away. The second one, 61, that's 2 away. 62, that's 1 away. 63, that's right on, that's 0. 64, that's 1 away. Another 64, 1 away. Another 64, 1 away. And a 67, that would be 4 away. Then they take their mean of those numbers. They add them all up, divide by how many numbers there are, and in this case, the girls' MAD, or mean absolute deviation, is 1.75. Then they did the same thing for the boys. They added up all of the numbers, divided by how many there were, and found a mean of 65. They went through and found how far away each number was from 65. So 60 was 5 away, 61 was 4 away, 62 was 3 away, 62 was 3 away, 64 is 1 away, 65 is right on, 72 is 7 away, and 74 is 9 away. So then our last step is to take the mean of how far they are away from the mean. So I add them all up, divide by how many there are, and I found that for the boys, my mean absolute deviation is 4. The last part is to describe what that means. So it says the mean absolute deviation for the girls' height is much less. It's 1.75 compared to the boys of 4 than that of the boys' heights. So the data for the girls are closer together than the data for the boys. And I know it kind of seems confusing because you're like, well, look at this, look how close this is. But if you're thinking about the spread here and how far apart they are to the mean, to the center, notice our center on this one was 63. So they're all pretty close to the center, where here our center is 65. So we have a few that are kind of farther away, okay? And we can tell that, so we have some higher numbers in this case than here, the distances. So then there was a got it problem. This got it problem takes a while, so instead of working it out with you, I'm going to show you the answer to it. So it says, the dot plot shows the high and low temperature in Denver, Colorado during 1 week. Find the mean absolute deviation for each set of data, round to the nearest hundredth. That's important in this problem, round to the nearest hundredth. Then write a few sentences comparing their variation. So the first thing is always to find the mean. They took all of their data points, added them up, divided by how many there were, and found our mean. Same thing on the other side. Added up all of our points, divided by how many there were, found our mean. Then you find how far each point is away from the mean. This one was really tricky because it had decimals to the hundredth place. So it was a lot of work taking these and subtracting each one. Remember, when you subtract, you're always going to just use positive numbers because these are distances. Once you have all of your distances, notice we did the same thing over here. Some of these I didn't rewrite the work because it was the same number over again. Notice how there was 2 dots there, so it was the same work. Then you take your mean one last time. So I add those all up, divide by how many there are to find my MAD. Add up my distances, divide by how many there are to find my MAD. In this case, the mean absolute deviation of the higher temperatures is greater than of the lower temperatures. My mean absolute deviation on this side was greater than on this side. So what that means is the lower temperatures are closer together. Okay? The lower temperatures are closer together. And you can kind of tell that on here. Notice on here there's a lot more lines to it even that can kind of gave you the hint. Though remember, the range is not an indicator of which one will be the greatest mean absolute deviation. Sometimes it could work against you if you're using the range to tell which way. Okay? Let me know if you have any questions. I'd be glad to help.